So today what we're going to be talking about is why we did all of those row operations yesterday, okay? The reason we did them was so that we can solve a system using something called Gaussian elimination or reduced row echelon form, okay? We're only going to work one or two of them by hands ourselves. Then I'm going to show you how to let your calculator do it, okay? But I want you to kind of know what the calculator is doing so you'll know kind of how it's working so it's not just coming out of nowhere. So yesterday we did some row operations and we started to figure out what some of those legal operations were. Okay, so to actually apply operations, you have a couple things you can do. You can multiply any row where's my eraser? Nope, that doesn't work. Sorry, that says row. This is a new way of writing. I apologize. Multiply any row by a non-zero scalar. Your next option is to switch any two rows. That's a legal operation. And your third option is to add a multiple of a row to another row to obtain a new row. So part 3, or rule 3, is what we were doing yesterday. We were adding row 1 plus 2, row 2, and we replaced it row 1 with that. Okay, that's like what your homework was yesterday. You were doing stuff like number 3. The goal, okay, the goal is to get a matrix that looks like this, where it says end goal, because we want to be able to solve for one of our variables. So if we get all zeros down here, then we're able to say, okay, something about z is equal to a number, and I can solve for that one. Okay? So let's look at number 1. Okay? And this is actually number 7 from yesterday. So using what we learned yesterday, the first thing we're going to do is going to create an augmented matrix. Okay? Now, in order to create that augmented matrix, we have to fix which equation? The second and third equation. How should we rewrite the third equation? 0x plus 1y plus 2z equals 10. And how should I rewrite the third equation? Okay, 0x minus 1y minus 1z sorry, I just need to figure out where are the erasers. Equals negative 6. All right, so let's write our augmented matrix. So our top row would be 1, 2, 1. And what would go on the other side of our little line? 5, our constant. And then 0, 1, 2. And then we would have 10. And then 0, negative 1, negative 1. We get negative 6. All right, yesterday they told us to do the operation R2 plus R3, and we're going to replace R3 with that new row. So we're going to let R2 plus R3 be the new R3, be the new row 3. So let's go ahead and do that. Does row 1 change? Nope, so go ahead and recopy row 1. 1, 2, 1, 5. Does row 2 change?
No.
No. So 0, 1, 2, 10. And row 3 is now going to be the sum of row 2 and row 3. So 0 plus 0 is still 0. 1 plus negative 1 is 0. And 2 plus negative 1 is 1. 10 plus negative 6 is 4. So the reason that we would do that is, notice we've created zeros in our bottom left corner, like our goal says at the top, right? And we've been able to see that we've created this. Yeah, so what that means is that 1z, or just z, is equal to 4. So once we know z equals to 4, what can we find pretty easily? Y. Pick either of your second equations that just have y and z. Okay? We've got y plus 2z, so y plus 2 times 4 equals 10. So y plus 8 equals 10, so y equals 2. Then we've got z and y, so plug that into our original. So x plus 2 times y, so 2 times 2, plus z plus 4 is equal to 5. So I'm using that top equation up here. Okay? So x plus 4 plus 4, so that's going to be x plus 8 equals 5. So what would x equal? Negative 3. All right, and how do we write our answer? Yep, x, y, z in ordered triple, negative 3, comma 2, comma 4. Madison? So that's the lesson that you missed yesterday. But basically what you're doing is you're adding row 2 and row 3. So we're adding each element. So 0 plus 0 gave us this 0. And 1 plus negative 1, 0. 2 plus negative 1, 1. 10 plus negative 6, 4. Okay? Okay. So we're going to do one more of these by hand, but then the rest of this we're going to let our calculator do. Okay? So let's look at number 2. Okay, so we are already in an augmented matrix. They already did it for us. Okay, so our goal is going to be to create zeros in those bottom 3 spaces. Okay, or at least that bottom row. So I'm going to go ahead and kind of walk you through some steps. The route I take is not the only route there is to get this matrix to work. Okay, but I just want to kind of just see how it works. So the first thing we could do is we could take R1 minus R3 and put that in the place of R3. All right, so let's keep R1 and R2 the same. So 1, 2, 3, 9. 0, 1, negative 1, negative 4. And then for our row 3, we're going to take row 1 and subtract row 3. So what's 1 minus 1? 0. And what's 2 minus 4? 2. And what's 3 minus negative 1? 4. Good. And 9 minus negative 5. 14. Okay, so did we create another 0 for ourselves? Yeah, that's good. Now we need to get rid of this negative 2. So what do you think we could do? Multiply. Yeah, we should multiply row 2. Yeah. If we double row 2 and add it to row 3, would we make that negative 2 go away? Yeah. Huh?
Oh, I was thinking like before that, why do you just multiply all in one?
You could have, like I said, there's a lot of different routes to get here. This is just, I'm showing you one pathway, okay? All right, so let's give that pathway a shot. So I'm going to do 2 times row 2, and I'm going to add that to row 3 to become my new row 3. I'm going to have to write kind of small. So row 1 stays the same. Does row 2 change? In my final matrix, does row 2 change? No, so go ahead and recopy that. All right, I'm going to double row 2. So that's 0, 2, negative 2, negative 8. And I'm going to add it to row 3. So 0 plus 0 is still 0. 2 plus negative 2, 0. Negative 2 plus 4 is 2. And negative 8 plus 14, 6. Okay, so did we create zeros in the 3 places we needed them? Yep. So go grab that little equation it gives us. What does that tell us? 2z equals 6, so what does z equal? 3. Okay. Look at these other little equations we've created. So look at this second row. What's the second row we've created? 1y plus, or sorry, there's a minus sign here that I forgot, right? There's our minus. So 1y minus 1z equals what? Negative 4. So we know that z is now 3. So y minus 3 equals negative 4. So what does y equal? Negative 1. All right, and then use that top equation. X plus 2y plus 3z equals 9. So x plus 2 times negative 1 plus 3 times 3 equals 9. So negative 2 minus 9. Or sorry, that's a plus sign. My bad. Negative 2 plus 9 is 7. So x equals 2. So 2, negative 1, 3. Okay? Now, you can see how this could take a long time, right? There's a lot of different routes you could take. It takes a long time to kind of brainstorm what to do, which row operations to use. So we are going to let our calculator help us out. So I'm going to recopy the original matrix we were given on number 2 on the back page if you want to do the same. I copied that right? Okay. So open up your calculator. This is another way to solve in your calculator. So open up your calculator and go into matrix. So second x inverse for our matrix. And this time we're only going to edit matrix A. What are the dimensions of the original augmented matrix we were given? 3 by 4. So 3 enter, 4 enter. 3 rows, 4 columns. So you're going to enter in all of your stuff, all of your entries from matrix A. So 1, 2, 3, 9, 0, 1, -1, -4, and 1, 4, -1, -5. All right. Once you have your matrix entered, quit and go back to your home screen by doing second mode. That's how you quit. Okay. Then you're going to do second matrix. And you're going to arrow over to where it says math. You see where it says math on that top row? Arrow over there. And you can arrow down until you hit B. Or you can do alpha. See that B in green? You can do alpha B. Or you can do nothing because your computer is going to freeze. Come on, you can do it. We're so close. Okay, well, you try it. Arrow down until you see B, and it's going to say RREF. Okay, where it says RREF, press enter. Okay, then you need to put in the matrix there. So you need to do second and go get your matrix A. Pause. So we're here on our home screen. We're going to do second. We're going to do second matrix. We're going to arrow over to math, and we're going to either scroll down till we hit B. You want RREF, not just REF. You want RREF, okay? Then you have to go put in that matrix. So go get your matrix again. So second matrix and select A. You don't have to close your parentheses. You will end up with this. Okay? So let's write that. Let's write that here. Let's write what we got. We get 1, 0, 0, 2, 0, 1, 0, -1, 0, 0, 1, 3. Okay? Now what that means is that solves our system for us. So here, it tells us that 1x is equal to what? Look at that top row. X is equal to 2. Y is equal to -1, and Z is equal to 3. So what your calculator just did was a bunch of row operations to create this new matrix. Okay? So let's try that again, hopefully without 19 interruptions. So first thing you're going to do is write your system as an augmented matrix. Okay? So if I write this as an augmented matrix, I'm going to have 1, 2, 3, 9, 1, 3, 2, 5, and 1, 4, -1, -5. Everyone go with that? Okay, let's go enter that in to our calculator. So second matrix, edit matrix A. Okay, what do you do after you enter everything in? Quit out of there. So second mode to quit. Okay, go pull it up again, or you can do second enter. Okay, if it's already there, you can do second enter, but let's try pulling it up one more time. We go second matrix. Where do I arrow? To math. You can arrow all the way down to B, or you can do alpha, B, and that will pull it up, reduced row echelon form. And then we want matrix A. So second matrix, choose matrix A. And we end up with the same answer. It wasn't the same system, but it just gave us the same answer. Okay? So how do I write that, though, as my answer? Yep, 2, -1, 3. What are we going to need to do in number 5? Before we can make our augmented matrix, what are you going to need to do? Yeah, you're going to need to add in 0x. So go ahead and give that a try. Create your augmented matrix and come up with your solution. All right, so you should have gotten 35, 52, 41. Everyone okay with that? Okay, number 6. I want you to write in a new system, please. Don't worry, this is one of your homework problems, so I'm really making you have less work later. So x plus y plus z equals 9. X plus y plus z equals 3. And 5x minus 2z equals -1. Just hang on. Just copy it down for now. We'll talk about it in just a second. Some of you are noticing some things, and that's great. We're going to let our calculator notice it first, and then we will talk about it. All right, let's set up our augmented matrix here. We're going to have 1, 1, 1, 9. Then we're going to have 1, 1, 1, 3. Then we're going to have 5. How many y's on that bottom row? 0, -2, -1. All right, I want you to go ahead and enter this into your calculator. Even if you already know the answer, I want you to go ahead and enter this into your calculator because I want to show you what it looks like on your calculator. Okay? All right, so if I press enter again, it'll do it for me. Look at what we've got here. I'm going to take a second. I'm going to copy that down for my answer matrix. It gave me 1, 0, -4, 0. It gave me 0, 1, 1.4, 0. And then it gave me all zeros and 1. Tell me what that means on this bottom row. Yeah, it would mean that 0 equals 1. Is that a true statement? No, not a true statement. Anytime we get a false statement when solving matrices, what's our answer? no solution. Now, some of y'all recognize that at the beginning. Can we have the sum of three values be two different numbers?
No.
No, that can't happen. And if we did R1 minus R2, for example, we would get 0, 0, 0, 6. So we would have gotten another row operation where 0 would equal 6. Can any of those work? No. So that tells us that this is a no solution. What, however, if we got 0 equals 0? Yeah, it's true, so it's infinitely many solutions. Okay? So if your calculator does something weird, think about what it means to create your answer. Okay? This is your homework, except now that we just did it, you can skip number 15. Because what we just worked on number 6 was number 15. Okay?
Wait, what's the yellow?